Hey guys, today we're going to cover points, lines, and planes. This is mainly a vocabulary day. So most of what we're learning today doesn't really have a whole lot of numbers to do with it. It's really a lot more about vocabulary. So the first thing we're going to cover is a point, and it's a location that has no shape or size. It's given a name by the word point. You always write the word point first, and then the capital letter that is by that dot that you see. So this over here is an example of what a point would look like. You know it from Algebra 1 as just being a dot. In reality, it's a location. So if you think about the room you are currently in, if there was just a spot in the middle of the room, think about like dust flying around the room. It's the location of that little dot of dust if you were to pause time, because you know dust moves constantly. So you can think of that as a point. So this one, because it's a dot and has an A next to it, its name is point A. And that's the only name it could have. The next thing we're going to cover is a line. And a line has exactly 2 points, and it goes forever in either direction. And the way that you name it are the 2 points that you see on the line. You're going to use those 2 letters, and then on the top of those 2 letters will be a drawing of a line. And I know that I'm coming back and all these words are just appearing, so pause your video to write down these sentences. There's no reason to get upset about it. Just pause the video. And I do this so that the video is not quite as long as it would be if you watched me write it. And then this is an example of a line. It actually could have 3 different names. So first of all, the 2 points on the line are P and Q. They don't have to be in any specific order. So the line name could be PQ, and you're going to have a little line on top of it. It could be QP. Typically, they're seen in alphabetical order, but either one is okay. And then this line specifically also has a little cursive lowercase letter. And anytime you see that, you can also name the line that cursive lowercase letter. But if that happens, if you're going to name it just the lowercase letter, you have to use the word line in front. So it would be line and then the cursive M. So I know that looks kind of funky, but you know, it needs to be a cursive looking M. The next thing we're going to cover is a plane. And, first of all, an example of a line, sorry, let me go back, is if you look at the side of a piece of paper, it actually has no width. And a piece of paper, of course, does have width, otherwise you wouldn't be able to touch it. But if you think about the side of a piece of paper, it's a good kind of example if that piece of paper was infinitely long. It would go on forever and ever. And if you just look at the side of it, that would be a good example of a line. It's really, so let's say you have 2 pieces of dust floating around your room. And if you connected those 2 pieces of dust, that would be a line. And you can't actually physically see a line. Anything in 1 dimension or 2-dimensional space, a person cannot physically see. It's more of a concept. So a point is 1-dimensional and a line is 2-dimensional, and people cannot physically see them. So we represent them as a dot for a point or as a straight line for a line. A plane, however, people can see. It is a flat surface made of at least 3 points and goes on forever in all directions. The thing about a plane, though, you can think of it as a piece of paper, but it would be an infinitely big piece of paper. It would go on forever and ever. But we represent it usually with something that looks like a piece of paper. You know, if you turn a piece of paper to its side, it is harder for you to see. But in reality, a plane, if you were to turn it on its side like a piece of paper, it would disappear to the human eye. So a plane is really, you can only see it if it's facing you. If it is turned sideways at you, you shouldn't be able to see it at all. And that's three-dimensional space. So again, a plane is a flat surface made of at least 3 points and goes forever in all directions. And the way that we name a plane, there are two ways to name it. You can either name it with the 3 points that make up that plane, and in that case, you would use the word plane, or actually, in all cases, you're going to use the word plane. So it would either be plane, and then you would list the 3 letters, or if there is a cursive letter on that plane, then you would name it plane, and then that one cursive letter. And that cursive letter will always be uppercase. It will never be lowercase. So a line is always lowercase. And then a plane's name will always be uppercase for the one letter. So again, it's the word plane followed by either the 3 points on the plane or the cursive uppercase letter. Okay, so this plane can have lots of different names because you would use the word plane and then you would list the 3 letters, which are B, C, and D. So typically you will see it in alphabetical order, but it doesn't have to be that way. It could be plane C, B, D. It could be plane C, D, B, and you get the idea. They could be in any order. You usually see it in alphabetical order, but it could be any of those using the 3 letters. The other way is the cursive K. So you could also call it plane and then that's a terrible cursive K, sorry. And then a cursive K. It's also pretty bad, but you get the idea. A line segment is the part of a line with 2 endpoints. So it has a definite starting point and an end point. There's no arrows and it doesn't go on forever. So if we were talking about the 2 pieces of dust floating around your room, they would start with one piece of dust, go to the other piece, and stop at that piece of dust. And again, remember, you can't see line segments, not in reality, but we do represent them as a straight line between 2 points. And then we also name line segments, very similarly to the way that we name a line, except instead of drawing a line on top with 2 arrows, you just draw the line on top of the 2 letters that are part of that segment. So this line segment can be named either AB, and you will draw a little line on top. And as you can see, that is different from line up above. This line has arrows on it, and this line segment does not. So that's the difference between the two, and it's how you'll know if we as teachers are talking about a line segment or a line, depending on how it's named. And then also this line segment can be named, oops, I did not put that back on a pin, sorry, can be named BA. Although you will typically, again, see it in alphabetical order. Next, we're going to talk about array. So array has 1 endpoint and goes forever in the other direction. So let's again bring up the 2 pieces of dust in your room. It would start at 1 piece of dust, and that's the starting point, and that's a definite spot. And then it would go through the other piece of dust and keep going in that direction forever and ever. So it's kind of like you take a line and you cut it off at one of the points. And again, segments and rays are both 2-dimensional, so in reality you can't see them, but we do represent them as these lines on a piece of paper. So the way that we name a ray is you must start with the end point first, the point where it starts, and then you're going to name the other point. So it does matter how you name a ray. It cannot go one way or another. It can only be named one way. So it'll start with the end point, and then it will name the other point, and it will have a small ray drawn on top, and it's always going to go from left to right. So this ray that you see pictured here is named A, B, and it will be drawn like this. And that's the only way it can be named. You cannot name this BA because it doesn't start at B, it starts at A. If you were to have a ray that looks like this, this one would be named BA because and you would still draw the ray for the name from left to right. Whenever you name it, the rays always go from left to right, regardless of how it's drawn. Because remember, rays can also be drawn vertically, horizontally, diagonally. It doesn't matter. But when you name it, you will always name it from left to right. So the left letter will always be the endpoint it starts with. So this one that I drew over to the right, let's name it XY. So, and it would be XY with an arrow going from left to right. So the names very much matter on rays. Make sure that you get those names correctly. Or name them correctly, sorry. Opposite rays are two rays that go in opposite directions from each other. And they always start at an endpoint and then they go in opposite directions from each other. So they look like a line with a midpoint, but that midpoint is really the starting point of the two rays going in opposite directions. And again, opposite rays are also two-dimensional and you can't physically see them, but we represent them as a line on a page. And then opposite rays are always going to be two rays named from that starting endpoint. So you're going to actually have two separate names because they are two rays, and they will always start with the endpoint and then it goes through the other point that it goes through. So I'll show you on our example as well. So in this example, we have two rays. Ray 1 is BA because it starts at B and goes through A. And then, I should name it Ray 1, sorry. And then Ray 2 is going to be named BC because it starts at B and then goes through C. And they are opposite rays. And together they make a line that you can name AB. You could name it AC. You could name it BC. There's lots of different names that you can name the line that is created by these opposite rays. But as far as the opposite rays are concerned, these are the names of those opposite rays, and they cannot be named anything else. Collinear points are three or more points that lie on the same line. And the reason why they can't be two, because any 2 points will always be collinear because 2 points make a line. So 3 or more points that do lie, they're collinear. 3 or more points that do lie on the same line. So an example is a line, and then you put 3 points on there. And it could be 4 or 5, it doesn't matter. But you need at least 3, and you can name them whatever. So in this case, what you would write is points, because they're always points. We're talking about points here. We're not talking about the line. We're talking about points. So points A, B, and C are collinear. Non-collinear is the opposite of that. So 3 or more points that do not lie on the same line. So example of that would be if we drew a line, we had points A and B making that line, and then point C is floating around out here, not on that line. So in this case, you would say points, because again, we're talking about points, not about the line. Points A, B, and C are non-collinear. They're not on the same line. Coplanar are 3 or more points that lie on the same plane. So it's similar to collinear, except in this case we're talking about a plane. So before we were talking about a line, coplanar would be 3 points that are all on the same piece of paper in that type of situation if you're talking about a plane. So an example of that would be a plane. Planes are usually represented by some sort of parallelogram. And then you have 3 points drawn on there. So in this situation's points, because remember we were talking about points. We're not actually talking about the plane. We're talking about the points that are on that plane. So points A, B, and C are coplanar. Non-coplanar is similar, and there's some confusion, well, some debating on whether non-coplanar is 3 or more or 4 or more. And the reason why is just like with collinear, you need at minimum 2 points to make a line, which is why 3 makes more sense for it to be non-collinear, because you have the 2 points that make the line plus 1 that's not on there. To make a plane, you have to have 3 points on that plane. So in order for it to be non-coplanar, you would really need 4, because any 3 points can create a plane. So I'm going to say 4 or more points that do not lie on the same plane. So an example is if you have plane ABC, remember planes have to have 3 points in order to make a plane. So you have plane ABC, and then you have point D over here. So in other words, you have a piece of paper, and then under that piece of paper you have a little flying piece of dust. So it's not on that paper, it's below it. So it's non-coplanar, it's not on that plane. So points, because remember again, we're talking about points. We're not actually talking about the plane itself. Points A, B, C, and D are non-coplanar. So this says, use the figure to name each of the following. A line containing point W. Well, point W is right here, so it's only on one line. The problem is that you could name that line many, many different things. So that line could be named VW. It could, of course, be named WV. It could be named VX or XV. It could be named WX. All of these are the exact same line. It just can have many names. Just like with people, most people have at least 2 names, your first and your last name. Some of us have 3 names because we have a middle name. I had a student at Hubble once that had, I think, 7 names because they wanted to name him after so many people in their family. So just like people can have many, many different names, and that doesn't even include all of our nicknames that we give each other, lines can have many different names, but they're all talking about the exact same line. It could also be X, Y, but you get the point. You just need to name any 2 points on that line, any of them, and then draw a line above. It can also be named line N because it has this little lowercase n right here for that line. And then it says a plane containing point X. Well, point X is right here. And again, that plane can be named many different things. First of all, it can be named plane and then a cursive P, which is basically the same thing because of that P. But then if you're talking about the letters, there are 1, 2, 3, 4, 5 letters on that plane. There's V, W, X, Y, and Z all on that plane. T is above the plane, and R is the line that makes that line that goes to T. So those aren't on there. And N is naming that line. It's not naming the plane. But you can name it any combination of those 3, of any of those 3 circled letters. So as you can see, it can be a lot of different names. So you would just pick one. And remember, it does have to start with the word plane. V, WX. It could be plane XYZ. Also, just for future reference, since you guys are new to my notes, I will always write a Z like this. And the reason is because I write a 2 like this. And it's really kind of hard to tell if I'm writing a Z or a 2. So my Z's will always have a line through them so that you can understand the difference. Intersections. Intersections are a point, a line, or a curve where two objects touch, and it depends what we're talking about on which one of those it will be. So two lines intersect at, so let's draw it. We have a line. We have another line. Well, they only touch right here, and we call that a point. A line intersects a plane at, so let's draw a plane. Okay, so what I want you to picture, because this is kind of hard to draw where you can actually picture it. I want you to draw I want you to picture a piece of paper, and then you stab a pencil through it. So this line is going through this piece of paper. It's going all the way through it. I know it's hard to tell. But again, it's like a pencil being stabbed through a piece of paper. So they intersect at a point. The only time that doesn't happen is if the line actually lies on the plane. In other words, you draw a line on the piece of paper. But if we're talking about intersections, they intersect, they intersect at a point. Two planes intersect at A. So in this case, I want you to picture a piece of paper and another piece of paper sliding through the middle of it. It's kind of hard to think of. And I don't know if I'm going to draw this quite right. We'll see. So that's a piece of paper with another one going through it. It kind of looks like the back of a paddle on a paddle boat, where those paddles intersect. They intersect at what I drew right here, and they intersect at a line. And we're almost done, I swear. Vocabulary just takes a while because I need to explain it so that you can really understand it, and hopefully you do. But now we're going to apply some of those things. So how many planes appear in this figure? All right, so you have this one. You can think of this as it's kind of like a pyramid, but it's a 5-sided pyramid instead of a 4-sided pyramid. So that's 1. Then you have this one back here. That's 2. And this one back here. That's 3. You have this one here. And that's 4. Then you have this one in the front here to make 5. And then you have the bottom that it's sitting on. So all of this, that makes 6. So there are 6 planes. Name 3 points that are collinear. So 3 points that are on any one line. Well, this line that's here is the one that most people go to, but it only has 2. So we can't use that line. So the only line, this line has 2, this line only has 2. So as you can see, there's a lot of them that only have 2, but there's only one that has 3. And that's this side of this. We call this a pentagonal pyramid. It's a 5-sided, like a pentagon is a 5-sided object. It's a 5-sided pyramid. So a regular pyramid, like what you would see in Egypt, only has 4 sides. This one has 1 additional side. So it's 5 sides, a pentagonal pyramid. So this line of the edge of that pyramid is J, K, and D. And points. So if we're going to name them, you got to use that word points. Name the intersection of plane HDG. So let's find plane HDG. HDG. So that's this front face triangle of this pyramid. So that's plane HDG with plane X. So plane X is the bottom. So this whole, it's kind of like a pentagonal pyramid sitting on a piece of paper. So X is the piece of paper. So where they intersect is this. Remember, two planes always intersect at a line. In this case, it's actually a segment, but you get the idea. So it's that segment, and in case you can't see the letters that I just circled a jillion times, it was HG. Remember, it's a segment, so you just draw the line on top. In other words, these don't keep going forever and ever. That would be a line. It's not a line, it's a segment. At what point do line LM, so let's find LM. LM is right here. So it's like the pencil going through a piece of paper. It goes through this plane. LM and line EF, where's EF? EF. At what point do they intersect? Well, as you can see from my highlighting, EF is a segment, so it doesn't keep going forever and ever, so they don't intersect. And we're done with notes.